Case Study: Revolutionizing Cybersecurity, TechGuard's Journey in Integrating Recurrent Neural Networks for Advanced Threat Detection and Response. Cyber defense is on the brink of a revolution, thanks to the advent of recurrent neural networks. Sarah, the Chief Information Security Officer at TechGuard Solutions, was acutely aware of this potential transformation. TechGuard, a mid-sized cybersecurity firm, had long relied on traditional neural networks for threat detection. However, with the rise of sophisticated cyber attacks, Sarah recognized the need to pivot towards more advanced machine learning models. Her team, comprising seasoned data scientists and cybersecurity experts, was tasked with integrating RNNs into their cybersecurity arsenal. TechGuard's first challenge was network intrusion detection. Traditional methods had been falling short as they depended on predefined signatures that attackers could easily bypass. Sarah wondered, can RNNs identify network intrusions even when the attack vectors are unknown? To explore this, her team examined a study by Kim et al., which deployed RNNs to detect distributed denial-of-service attacks by analyzing network traffic patterns. By training an RNN on normal traffic data, the model learned to recognize deviations that signified an attack, achieving high accuracy in detecting DDoS intrusions. Next, Sarah focused on anomaly detection. Traditional systems often missed stealthy attacks that did not follow known patterns. She asked, how can RNNs enhance our ability to detect these subtle anomalies? Her team delved into the research by Malhotra et al., where an LSTM-based RNN was applied to time series data for anomaly detection. The model was trained on normal operational data and subsequently flagged sequences that deviated significantly, thus identifying advanced persistent threats that traditional methods overlooked. User behavior analytics was another critical area that Sarah aimed to improve. Insider threats and compromised accounts were increasingly becoming a concern. She questioned, can RNNs effectively monitor and analyze user actions to detect potential threats? A study by Ebel et al. Provided insights, demonstrating how RNNs could model user behavior and detect anomalies indicating malicious activities. By analyzing sequences of user actions, the RNN flagged deviations that suggested insider threats, enabling proactive threat response. Anticipating future threats was also on Sarah's agenda. She pondered, how can we leverage RNNs to predict emerging cyber threats? Referencing a study by Brown et al., her team explored how RNNs could forecast future attacks by analyzing historical data. The model predicted the likelihood of various cyber attacks with high accuracy, offering valuable foresight that could inform proactive defense strategies. Sarah also saw potential in integrating RNNs with automated response systems to improve their efficacy. She asked, can RNNs provide more accurate, context-aware responses during cyber incidents? Drawing from Shaukat et al., her team developed an automated incident response system powered by RNNs. By classifying different types of cyber attacks and recommending context-driven response actions, the system not only improved accuracy but also reduced response time, thereby mitigating the impact of attacks. Despite these promising applications, Sarah was mindful of the challenges in implementing RNNs. One significant hurdle was the need for large amounts of labeled data for training. She wondered, how can we overcome data limitations in training our RNN models? Her team decided to employ transfer learning and data augmentation techniques. By leveraging existing data, they improved the model's performance and addressed the scarcity of labeled data for rare attack types. Another challenge was the complexity and interpretability of RNN models. Sarah questioned, how can we make RNN decisions more transparent for cybersecurity applications? Her team investigated attention mechanisms and model-agnostic interpretability techniques to enhance understanding of the model's decision-making process. These methods allowed them to visualize which parts of the data the RNN focused on, thereby improving trust and accountability in the system. Resource constraints for training and deploying RNNs also posed a concern. Sarah asked, how can we optimize the computational resources required for RNN implementation? Advances in hardware acceleration, such as GPUs and TPUs, were critical in addressing this issue. By utilizing these technologies, her team managed to train complex RNN models efficiently. Furthermore, They developed scalable algorithms to ensure the RNNs could operate in real time, essential for timely threat detection and response. As TechGuard successfully integrated RNNs into its cybersecurity framework, Sarah reflected on the journey. The transition was not without its challenges, but the results were compelling. Network intrusion detection became more robust, anomaly detection systems were significantly enhanced, and user behavior analytics provided early warnings of potential threats. Predictive models offered foresight into future attacks, and automated response systems became more effective and efficient. Sarah's experience at TechGuard highlighted the transformative potential of RNNs in cybersecurity. The ability to learn from sequential data patterns and maintain contextual awareness allowed RNNs to address complex challenges that traditional methods struggled with. However, the journey also underscored the importance of overcoming data limitations, enhancing model interpretability, and optimizing computational resources. For organizations considering a similar transition, Sarah's experience offers valuable lessons. First, start by identifying specific areas where RNNs can add value, such as intrusion detection or anomaly detection. Collaborate with data scientists and cybersecurity experts to develop and train the models, leveraging existing data and employing techniques like transfer learning to overcome data limitations. Ensure that the models are interpretable and transparent, using techniques like attention mechanisms. Finally, invest in the necessary hardware acceleration to handle the computational demands of training and deploying RNNs. By carefully navigating these steps, organizations can harness the power of RNNs to enhance their cybersecurity posture, anticipate future threats, and respond more effectively to cyber incidents. TechGuard's journey is a testament to the potential of RNNs to revolutionize cyber defense, providing a blueprint for others to follow.